Hello and welcome. In this video, we're going to be looking at one of the toughest questions that came in the Mechanics M1 Edexcel International A-Levels. This test is June 2017, and question 5 of this test has a very interesting part, which is part C over here, and you can see that it's an 8 marker. Let's move up. So 8 marks is quite a lot. So let's start by reading the question. Okay, it says that we have two trains, P and Q, that move on a horizontal, parallel, straight tracks. Initially, they're both at rest in a station and level with each other. At the start, or at time t equals 0, P starts off and moves with a constant acceleration for 10 seconds up to a speed of 25 meters per second. Then moves at constant speed of 25 meters per second. So it accelerated, took 10 seconds, and then it continued at this velocity with 0 acceleration. At time t equals 20, which is 20 seconds after train P started to move, train Q started to move in the same direction, and train Q accelerated with the same acceleration as P. But it didn't accelerate up to a speed of 25. However, it kept accelerating up to a higher speed of 40 meters per second, and then it moved at this constant speed of 40 meters per second to continue with that speed. Train Q overtakes P at time t equals capital T after both trains have reached their constant speeds. So overtaking means that they are both at the same position at the same time. And it says that this overtaking happens, so they both reach the same position at the same time when they both are moving at constant speed. So after okay, so it says that this overtaking happened after they both reached their constant speed, so after they both accelerated. So part A tells me to draw and sketch on the same axes a speed time graphs of both trains. Okay, let's start by drawing the speed time graph. So this is time in seconds. This is speed, let's call it V in meters per seconds. And let's start by drawing what happens to P first. So P moves at a constant acceleration for 10 seconds and it reached a velocity of 25 meters per second. Okay, for a VT graph, I know that my gradient or my slope is equal to my acceleration. Why? Because gradient is basically rise over run or y over x. Y here is v over my x is t, and v over t is acceleration. So what I'm trying to tell you is that acceleration is the gradient. If it says that it moves with a constant acceleration, it means that my gradient is constant. And I know I have a constant gradient when I have a straight line. So basically this is what's happening. P is moving until it reached the speed of 25 and then continued at that speed until we reach the end, which was capital T. This is where the overtaking happens. So this is basically P. Right, let's think about Q. What happened to Q? Q started its journey at time t equals 20 seconds. So let's say it started from here. So it's no longer starting from the beginning just like P. No, it started from t equals 20 and it moved with the same constant acceleration. If it moved with the same acceleration, then it's supposed to have the same gradient as that first initial line. So let's try and draw it. Okay, and it said that it reached a speed of, let's say this is 40. Okay, and then it started moving at a constant speed until it reached t. So this is what's happening to Q. Let's just erase this part and draw it over here. So that is P and that is Q. So basically this is the speed time graph. However, I need to know one thing. I need to know what was the time that Q accelerated for. right? So how can I say that? How, first of all, the acceleration of Q is the same as acceleration of P. So let's start by getting the acceleration of P. So for P, what do I have? I have the initial velocity, which was 0. I have the final velocity, which was 25. I have the time, which was 10. And I want acceleration. So the letter that I didn't mention was S, or the displacement. So I'm going to use the equation without displacement, which is V equals U plus AT. So 25 equals 0 plus A times T, which is 10. A is basically 25 over 10, or A equals 25 meters per second squared. This is the acceleration for A, which is the same as the acceleration for Q. So let's think about Q now. Let's see, what do we have? We have the initial velocity, which was also 0, the final velocity, which was 40, and the acceleration was 2.5 meter per second squared. Okay, these are meter per second. This is 10 seconds. And I want the time. How long did Q spend accelerating until it reached 40? So what's time? Again, I'm going to use V equals U plus AT. So 40 equals U plus AT. So T equals 40 over 2.5, which is 16 seconds. So the time Q spent accelerating is 16 seconds. So from here until it accelerated, so from the starting point until it reached the constant velocity, it took 16 seconds. So if I have 20 plus 16, so basically this over here is 36. And this is my speed time graph. Okay. B asks, find the value of T at the instant when both trains are moving at the same speed. Okay, when are both trains moving at the same speed? P moved 25 and then continued as constant velocity of 25. What time are they both exactly moving at the same speed? We can see that it's this point over here where Q is 25, and at the same time P is moving at 25 meters per second, and this part here is the point where we are interested in. So basically I want to know, when did Q reach a speed of 25 meters per second? So let's do the things for Q again. Now I have U is 0. My V is now 25. I want to check when was the final or the velocity 25 meters per second. I want to know the time, and I have my acceleration, which was 2.5. Again, I will use V equals U plus AT. So 25 equals U plus 2.5 T. So basically T equals 25 over 2.5, or T equals 10 seconds. So from here, after 10 seconds, Q is moving with a speed of 25. So this part over here, let's just erase this. Let's write it. So this part over here is 30, and this part over here is 36. So basically, this is what's happening. So our time was equal to 30 seconds, which is the initial 20, and then the 10 seconds after Q started moving for it to reach 25 meters per second. Okay, let's go for part C, which is super interesting. Okay, so part C. It says find the value of T, which is the time where Q overtakes P. Overtaking, again, means that they are both at the same distance or the same position at the same time. So when did this happen? It told me that this happened after both trains have reached their constant speed. So it happens after both trains reaches their constant speed. So basically happens after this period of time. So somewhere over here. So basically in the initial 36 seconds where Q didn't still reach its constant speed, they were not overtaking each other. It happened after the initial 36 seconds. So what we can do is we can try and solve at the first 36 seconds, where was P and where was Q from the train station. So at T equal 36 seconds, let's see where was P. So for P, to get this, I can get the area under the graph for P, because I know that in a velocity vt graph, area, which is basically x times y, so v times t, is basically the displacement, because velocity times time is displacement. So the area under the graph for a vt graph is displacement. So I can find the distance P moved up to 36 seconds by getting this area over here. And I know that this area is a trapezium. The formula for area of a trapezium is A plus B over 2 times H, where if I have a trapezium like this is A, this is B, and this is H. So let's do that. So over here, I know that my A is basically 30 plus my B, which is from 10 to 30. So my B, sorry, 36. My A is 36. I'm trying to get this area. I'm trying to get the area until 36. So my A is 36, okay, plus my B, which is from here all the way up to here. So it's 36 minus 10, so it's 26 over 2 multiply height, which is this distance over here, which is 25. So multiply 25. This is going to give me an answer of 775 meters. So after 36 seconds, P is 775 meters away from the starting position. Let's do the same for Q. So again, for Q, we can try and find the area under the graph for Q. So the area under the graph is basically the area of this triangle over here. I can use kinematics to find it, or I can use the area under the graph. Area under the graph, I can see that this is a triangle, so the area is half base times height, which is equal to half. Base is basically this, so from 20 to 36, which is 16, and my height is all of this, so it is 40. So half times 16 times 40, that is going to give me an answer of 320 meters. Or I can use kinematics as well to get it, and I can show you very quickly that I have u equals 0, I have v equals 40, I have my acceleration, which is 2.5, and I want s, which is the displacement. I can use v squared equal u squared plus 2as. So 40 squared equals 0 squared, which is u plus 2 times 2.5 times my s. So basically my s is 40 squared, 2 times 2.5 is 5. I will need to get rid of that, so I will divide 5 by both sides. So s is 40 squared over 5. 40 squared is 1600. Divide 5, that will give you an answer of 320 meters. So again, Q was 320 meters after 36. So let's try and draw what's happening over here. So let's say this is our train station, okay? So after 36 seconds, P was over here, okay? And this distance from the train station to where P is was 775 meters. And this point over here is point P. Q after 36 seconds again was only 320 meters away from the train station. So this is P, this is Q. The question tells me, when is the overtaking going to happen? So let's continue their track. Let's say they're gonna overtake each other, or Q is gonna overtake P at this point. Let's call it point O, point of overtaking. So this point is where P and Q are going to be at the same position. So let's call the distance from P to this point, let's call it, let's say x, okay? So basically the distance from P to the point is x. The distance of Q to the point is basically this distance plus x, because this is also x, and I need this distance. So what's this distance over here? It's basically 775 minus 320, which is going to give me an answer of 445, I believe. 455 meters. So what I have is that they're both moving at a constant velocity. Okay, so constant velocity has an equation of v equals distance over time. Okay, so let's see what's happening for q. The distance that I want for q is basically equal to 455 plus x. That's my distance until it reaches the overtaking point. And for p, the distance is basically just x. Okay, so vq was 40. It's moving with a speed of 40 equals s, which is 455 plus x, over the time it takes to reach this overtaking point. And let's do the same for p. So vp was 25 equals the distance, which is x, over the same time to reach the overtaking point. So now we see that we have two equations where we can solve simultaneously for time. So from here I can say that 25t equals x. I'm multiplying t both sides, these cancel. So I have 25t equals x, which I can substitute over into this x to solve for t. So let's try and do that. So 40 equals 455 plus, instead of x, I'm going to write 25t, which is this, over t. So I'm going to multiply t both sides. These t's are going to cancel. This is going to be 40t equal 455 plus 25t. I'm going to subtract 25t from both sides. This is going to be 40t minus 25t equals 455. So this is 15t equals 455. So t equals 455 over 15, which is equal to 30.33 seconds. Okay, so basically, once from this point where q was 320 away from the station and p was 775 away from the station, so basically after a time of 36 seconds, it will take 30 seconds for them to reach this point, which is q and p over here. So basically the total time from the start is going to be the initial 30 seconds for them to reach this point, and then the further 30.33 seconds that we calculated. So total time is going to be 36, the initial time, until they are both moving the same with a constant speed, and then adding the time it took for both of them to reach the same position at the same time. So my answer is going to be 66.333 seconds. This is one way to solve it. Okay. However, there is also another way which I want to tell you. Basically, this other way takes into account what's happening for the areas under the graph over here. So let's say, okay, this doesn't want to, okay. So basically, the distance that p moved when it reached t should be the same as the distance that q moved when it reached t. So basically, the area under the graph for p until t should equal the area under the graph for q until t as well. So those two areas should be equal, and if we equate them, we can find t. So let's start by trying to find the area under the p graph. So this area is also trapezium, so a plus b over 2h. So my a is basically going to be all of this, which is basically t. So let's do it over here. So t plus, okay, b, which is this side, which is from here all the way up to t, which is basically t minus this initial part, so t minus 10. So my b is t minus 10, and then over 2 multiplying my height, which is this height over here, which is 25. So this is 25. Okay, this should equal, let's let's erase this. So this should equal the area under the Q graph, which is also a trapezium. From here all the way to here is basically t minus 20. So this should equal A, which is t minus 20, and then adding B, which is this small part over here, which is t minus 36. So this is t minus 36 over 2 times the height, which was 40. The height of the black curve is basically 40. Okay, so now let's solve these together. First, we can cancel off these two. Let's add the t's together. So it's going to be 2t minus 10 times 25 equals 2t minus 20 minus 36 is minus 56 times 40. So let's distribute this 25 inside. 25 times 2 is 50t minus 250 equals 40 times 2 is 80t minus 56 times 40, that is 2240. Let's move this 50t to the other side and this negative 2240 to this side. So we're going to have 2240 minus 250 equals 80t minus 50t. So basically this is 1990 equals to 80 minus 50 is 30t. So our t is 1990 over 30, and dividing this is going to give me an answer of 66.333 seconds, which is the same as the answer that I got here. So basically these are two ways to solve this equation. For these equations, it's always best to draw and sketch the graph to know what is actually happening. Anyways, I hope this video was helpful. Please feel free to like, comment, and subscribe. If you have any topics or any questions you want to go through, leave them down below and I'll read them. Thank you for watching. Hope this was beneficial.